Hello everyone, I am Dr. Srinivasulu, Assistant Professor, Department of Electronics and Instrumentation Engineering, VNR VJIT, Hyderabad. In this video, I am going to explain you about the combination of measurement errors. So before going to explain about the measurement errors and how it is combined, let me recall you what was the measurement error and why to combine this measurement error. As I explained in the previous videos, the measurement error is the difference between the true value and the measured value. This measurement error will get due to the errors present at different points in the measuring unit. So the final measured error is due to the combination of all these errors. That's why to understand what are the different sources of errors and what is their contribution in the final measured error, we are going to discuss or explain here how we combine these measurement errors at different variables. We know that the variables or the parameters in the measuring unit will be combined in different ways on the final measurement. For example, if we take a resistive network where the resistors are connected in series, the equivalent resistance is the combination or the summation of all the resistances. So, the error present at each resistance is combined and produce the overall error at the equivalent resistance. And when we take the resistive circuit where the resistors are connected in parallel, will be having both the product of two resistors and the summation of two resistors, and finally the division of the two combinations. So we'll have variety of combination of resistances or the parameters and how they combine to the final measurement. So we'll see all these combinations one by one. In this video, I'll explain you the error combination of sum or difference of quantities and product of quantities. Let me start the first one, sum or difference of quantities. Suppose let y is the final measurement and it is having the two parameters u and v, where this u and v are related to y by the summation or subtraction. So we take either plus or minus u value and plus or minus v value. Now we take the change in y, that is dy by y. This is equal to, where change in y is nothing but the change in the combination of these two parameters plus or minus u plus or minus v divided by y. This is equal to, since this is the summation, the change can be splitted. So it can be written as plus or minus du by y plus or minus dV by y. Now this can be again written as plus or minus u by y into du by u, plus or minus similarly for dv by y. We can write it as y by v by y into dv by v. Now here du by u is nothing but the limiting error, relative limiting error that we discussed in the previous video. So that will be given by the manufacturer, and here u value is each variable nominal value that will be again given by the manufacturer, and u will be known, again nominal value of the final measurement, and v also the same, all are known values, and the limiting relative limiting errors du by u and dv by v will be given. Therefore we can finally calculate the relative limiting error of y like this. By using this formula we can measure it. So this formula will be useful to calculate the relative limiting error of the final value y with the help of the relative limiting errors of individual parameters when they are combined in summation or difference form. So from this we can understand that the relative limiting error of a measured value when this is related to the summation of two individual parameters, this is the relative limiting error of final value is depending on the relative limiting errors of the individual parameters. So this way we can calculate the relative limiting error. And the second case is when, so before going to the second case, let us see one example how we can calculate the relative limiting error for a series combination of three resistors circuit. So here the resistor values are given R1, R2, R3, and these three resistors are connected in series. Therefore, we want to measure the relative limiting error of final equivalent resistance. So that is delta R by R we need to calculate. So how do we calculate? This delta R by R is equal to, by the previous formula, it is R1 by R into delta R1 by R1 plus R2 by R delta R2 by R2 plus R3 by R delta R3 by R3. Here R1 is given here 50 ohm and R is calculated here 350, and delta R1 by R1, this is nothing but 10% of 50. So it is 10% of 50. 10% is 0.1 of 50 plus R2 by R. R2 is 100 ohm divided by 350 into R2 by delta R2 by R2 is 5% of 100. So it is 5%, 0.05 of 100 plus R3 by R, 200 by 350 into 10% of 200. So 200 into 0.1. This is equal to 50 by 350 into 5 plus 100 by 350 into 5 plus 200 by 350 into 20. After calculating this, we'll get 0.0857. So this is nothing but 8.57%. Therefore, the total resistance R is equal to 350 plus or minus 8.57%. This is the total resistance value that we'll get when we measure the equivalent resistance of this series circuit. Now we'll see the case of product of quantities. When we have the measured variable is of product of two variables, like suppose say V is equal to I into R, or in general we can take it Y is equal to U into V. To solve this, we take log on both sides of Y is equal to UV. Therefore, it will be log Y is equal to log of UV. This log of UV can be written as log U plus log V. When we take the differentiation on both sides, take differentiation on both sides, we'll be having d by dy of log y, d by dy of log u plus d by dy of log v. The differentiation of log y is equal to 1 by y. This is equal to log of u is 1 by u, but this is the differentiation is with respect to y. We'll be having du by dy plus similarly 1 by v dv by dy. Here we can take common 1 by dy, so it will be du by u plus dv by v, and this dy we can send to the left hand side. We'll get dy by y is equal to du by u plus dv by v, and this is the relation between relative limiting errors of individual parameters on the final measurement. So it is simply the summation relationship. Thank you for watching the video.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.